In trigonometry, sine, cos, tan, cot, secant, cosecant, how these ratios are defined. I will explain the derivation for these ratios in 5 minutes. Let's start the class. For that, I have taken one straight line here, and they have taken another line which is having theta degrees here. Okay. Now I will draw the few vertical lines here. So I draw one vertical line here, another vertical line here, and another vertical line here. Right. So it forms the 90 degrees here, and 90 degrees here, and 90 degrees here. Let's mark these points. So it's AB line, and this is CD line, and this is EF line. Right. Now if you observe, it forms the many triangles. So here OAB is the one triangle, and OCD is the another triangle, and OEF is the another triangle. Right. If you notice all these triangles are similar triangles. Why these are similar triangles? Because this is our A criteria similarity. What does it mean? Let me explain. If you notice OAB triangle, this theta degree is the common angle to all the triangles, right? So if you take OAB, theta is the common angle, and OCD triangle also, theta is the common angle. So it is the one common angle. And if you notice at point A, C, so it has 90 degrees. In a triangle, two angles are same for all the triangles. Third angle is automatically same. Why it is same? Because total angle sum in the triangle is 180 degree, right? So with this criteria, all these triangles are similar triangles. What does it mean? Similar triangles means their corresponding sides in the same proportion. Means, so if you divide with one triangle with another triangle with any of these sides, it will come some constant number. For example, this triangle and this triangle, if you compare, this larger triangle may be 1.5 times or higher than the first triangle, or 1.2 times, 1.1 time, like that. Okay. So if all these sides, if you divide, you will get that 1.1 ratio or 1.2 ratio. Okay. So that means their sides are in same proportional. Same proportional means if you take from the first triangle, this OA, and another triangle, if you take the second triangle OCD, it's a OC, right? So OA by OC equal to, similarly, OB by OD and AB by CD. Okay. So now what I do, right? I will take the first two terms in this equality terms. Okay. So OA by OC equal to OB by OD. Okay. So here OA and OB from the first triangle, and OC and OD from the second triangle. Right. Now what I do, right? I will make it for left hand side is from the first triangle, and right hand side from the second triangle. For that reason, I will send this OB term to here. Okay. So I just changed this equation to OA by OB equal to OC by OD, right? So it won't change any equation. Okay. Instead of talking OA, OB, OC, OD like that, I'll just define some names to the sides. Okay. Based on this theta angle. So let me take. We know that in this triangle, this is the hypotenuse. Similarly, in this triangle also, there is hypotenuse. So we are calling this is the hypotenuse, right? So let's name this as a hypotenuse. And I'm naming this side is, so this is a theta angle. So this side is just touching to the theta, right? Entire side is touching to the theta angle, right? So that we are calling adjacent to theta. So this OA, OC, OE, all this we are calling adjacent to theta. And when we check A, B, C, D, E, F, right? It is just opposite to theta, right? So we are calling opposite to theta, opposite to theta, opposite to theta. We are just named it, okay? To simplification. If you check with OA by OB here, if you check here, OA by OB here, so OA is adjacent to theta and OB is the hypotenuse. That means adjacent to theta by hypotenuse is coming from the first triangle, equal to this OC by OD is also adjacent to theta by hypotenuse for the second triangle. Even if you write for the third triangle also, it will come as a constant. That means adjacent to theta by hypotenuse is a constant number, okay? It is not changing with the triangle size. If your theta is fixing, if you are not changing theta, then you are changing different triangles with same theta angle and with 90 degree, another 90 degrees right angle triangle, then it is coming as a one constant number, okay? Clear? Similarly, if you take these last two terms, OB by OD equal to AB by CD, similarly, I will just exchange from the same triangle one side, okay? That is, here I send the CD by OD equal to AB by OB, isn't it? Okay, what is CD here? CD is the opposite to theta, right? So opposite to theta by hypotenuse is also constant is coming. Okay, if you take first term and last term here, okay, then you will get opposite to theta by adjacent to theta also constant. Here you need to remember only one point, okay? So if a fixed theta angle, okay, if you're not changing theta angle in a right angle triangle means, okay, all these combinations of ratios are constant, okay? It's a different constant. Here constant 1, constant 2, constant 3, maybe, okay? Like the different, but it is that ratio is constant, okay? It's clear, right? Now I will explain how sine, cos, tan are defined, okay? So already we have seen all these ratios are constant, okay? For example, if I given a constant to you, let me take a constant of some 0.2, okay? So if I give you a 0.2 constant, then you will ask the question, what is that constant is? Then I need to explain to you, this constant is opposite to theta by hypotenuse is the 0.2, okay? Okay, that's the constant you have given to me. So every time when you are talking like that, you need to tell that which is that constant. It is the opposite to by hypotenuse or adjacent to by hypotenuse or opposite to by adjacent. Like that you need to ask this question. Instead of asking, if you name this every side also, then easy to communicate, okay? So that they give another names for this. For example here, opposite to hypotenuse they named as a sine, okay? Similarly, adjacent to by hypotenuse they named as cos. And opposite to by adjacent they define as a tangent or tan, okay? Then why they are written here theta here? So this ratio is defined for theta angle, okay? So theta changes, this ratio is changing. Earlier I said, I given a ratio of 0.2 for the opposite side by hypotenuse I have given. That means sin theta equal to 0.2 if I put it directly, then you will understand it is a right angle triangle. For an angle of theta, this ratio is defined as 0.2, okay? That is a constant, it won't change 0.2 for the angle of theta. Then angle theta also fixed, okay? For particular angle, that ratio is coming 0.2, okay? So what you need to remember is, if you know this ratio, you know the angle. If you know the angle, you know the ratio, okay? So for each angle, like 1 degree, 2 degree, 3 degree, 4 degree, 5 degree, you have separate ratios. All these ratios are feeding into the calculator, okay? Then if you see in the calculator, sin 1 will get one ratio. Sin 2, 1 ratio will get. Sin 4 will get 1 ratio. Similarly, cos 1, cos 2, cos 3 also will get some ratios. Similarly, tan also will get it. That means, if someone is giving that ratio, okay, then you know the angle, okay? For what angle, that is their ratio. With this phenomena only, they will come to know heights and distance in the trigonometry. So I am writing here, let's say, take for sin theta means opposite side by hypotenuse, that is AB by AC. Similarly, I have written cos here, similarly I have written tan here, okay? So one point you need to notice is here, for example, opposite side by hypotenuse is a constant. Then obviously hypotenuse by opposite also constant. So we will be naming these reciprocals in different name. That is, sin reciprocal we are defining like cosecant, cos reciprocal we are defining like secant, and tan reciprocal we are defining like cot. Okay? Clear? So this is how all the ratios are defined, okay? And put these separate names for that, okay? If you have any questions, write in the comment section, okay? I'll try to address them, okay? Thank you for watching.